Okay, so in the situation in the previous exercise, show that the measure of arc ST, so ST is this SWT, this minor arc, is equal to 180 minus the measure of angle SPT. So notice this is the same situation as the previous exercise, but I extended OP to be PR, and where PO intercepts the arc ST, I put a W. Okay? And that's going to help us solve or, get this equation. All right, so proof. So by the previous problem, we found that triangle OSP, so OSP was congruent to triangle OTP, right? So we were able to conclude that in the previous exercise. So the important things that we're going to get out of this are that angle SPO is congruent to angle TPO, and angle SOP is congruent to angle TOP. Okay, so let me go ahead and arrange that. So this angle here is congruent to this angle, and this angle is congruent to this angle, right? Okay, so angle SOP is congruent to angle TOP, since these are both central angles, that means their corresponding arcs must be congruent, right? Since these central angles are congruent, that means these corresponding arcs must be congruent. So this implies that arc SW is congruent to arc TW. Okay? So now, by the exterior angle theorem, so I'm going to get a new color, so maybe red. So hopefully you guys can see that I'm going to try to show that this angle here is congruent to, I guess let me move this O a little bit, this angle here. I'm going to try to prove that those two are congruent by using the exterior angle theorem. So we have that the measure of angle SOR, which is this guy right here, right, is equal to, so remember the exterior angle theorem states that it's equal to the sum of the remote interior. So one of the remote interiors is 90 plus, and then the other remote interior is angle SPO, right? Plus the measure of angle SPO. And of course, 90 is equal to 90 plus SPO, remember, is the same as TPO, so the measure of angle TPO. Well, 90 plus the measure of angle TPO is the same thing as the measure of angle TOR. So this is equal to the measure of angle TOR. So by using this exterior angle theorem argument, I'm able to show that the measure of angle SOR is equal to the measure of angle TOR. So since their measures are the same, that means angle SOR is congruent to angle TOR. And since those angles are congruent and they're central angles, this implies that arc SR, because SOR is for arc SR, right? So this means that arc SR is congruent to arc TR. All right, so let's go ahead and color code these guys. So I know that this arc is congruent to this arc, and I know that this arc is congruent to this arc, and that's going to come into play. Okay, so I know the measure of angle SP PT, right? Okay, so now I know the measure of angle SPT, right? SPT is equal to half of the measure of arc SRT, right? So measure of arc SRT minus the measure of arc ST, right? The measure of arc ST. Okay? Now in this equation, I want to get rid of this 1/2, so I'm going to multiply both sides by 2 to get 2 times the measure of angle SPT is equal to the measure of arc SRT minus the measure of arc ST. So, remember, I have to get ST by itself, so I'm going to add ST to both sides and subtract SPT on both sides. So this implies that the measure of arc ST, right, is equal to the measure of arc SRT minus the 2 measure of angle SPT. Okay, so remember, I have ST is equal to 180 minus measure of angle SPT. So what I'm going to do here, I know this implies that the measure of arc ST is equal to the measure of arc SRT minus the measure of angle SPT minus the measure of angle SPT, right? Because 2 measure of angle SPT is the same thing as this minus this, right? Okay, so hopefully you guys can see that at least according to my equation up here, I have to somehow show that the measure of arc SRT minus SPT is equal to 180, right? So SRT, right? SRT, since arc SR is congruent to arc RT, I know that 2 SRs create SRT, right? So I can rewrite SRT as 2 measure of arc SR. And for SPT, I know SPT is made up of 2 SPRs, right? Notice that since this angle is congruent to this angle, 2 of this angle would create this whole angle SPT. So I can do minus 2 measure of angle SPR. SPR, right? And then of course minus the measure of angle SPT. Okay, so now this is equal to 2 measure of arc SR minus 2. So the measure of angle SPR, right, is the same thing as half of the measure of arc SR. So the measure of arc SR minus the measure of arc SW. And then of course minus the measure of angle SPT. And then 2 times a half is just 1, so I'm left with 2 times the measure of arc SR minus, right, so minus the measure of arc SR, and minus makes this plus, so this will be plus the measure of arc SW, and then minus the measure of angle SPT, and then this is equal to, so the measure of arc SR, or I guess 2 times the measure of arc SR minus SR is just the measure of arc SR, plus the measure of arc SW, minus the measure of angle SPT, and look at what we have. SR plus SW is in fact 180, because since WR is the diameter, right, that means the measure of this arc is 180 because this is a semicircle. So this implies that the measure of arc ST is equal to 180 minus the measure of angle SPT, which is exactly what we wanted to prove.